Welcome to my YouTube channel. My name is Neco. Please, if you are joining me for the first time, kindly hit the subscription button. Now, today I'll be taking you on the inorganic aspect of the chemistry practicals for Neco 2021. Now, the white paper is out and the salt required for analysis is ammonium carbonate. Here's the salt. And for us to carry out this analysis, we need reagents such as what? Dilute hydrochloric acid. We need barium chloride, which I drank here. We need lime water. I have all my reagents here with me. This concentrated hydrochloric acid. This is my distilled water. Now, this is the salt. First of all, there are things you need to know about ammonium carbonate. This is the only unstable salt of ammonia that decomposes on its own, even without heating. At room temperature, it decomposes to release ammonia gas. So this is the only unstable ammonium salt that decomposes on its own to release ammonia gas, even at room temperature. Now I'm going to be carrying out a series of tests to confirm the ions present in this salt. Remember, in the exam, the examiner will not tell you the salt. He will tell you sample C. The examiner will be like, C is an inorganic salt. Carry out the following test on sample C. Record your observations and your conclusions. That's how the examiner is going. That's how the equation is going to come. So, from the requirements or from the reagents given to you to test for this salt, you can actually carry out some necessary tests. You can actually carry out the following tests to confirm the ions present. Now, before I continue, please kindly hit the subscription button so you can watch out for more videos. I will also be producing videos on the biology practicals, on the physics practical as well. So please stay tuned. Now, let's get started. The very first thing is that I'm going to get my sample. I'm going to use a spatula to get my sample out, like you can see here. At the end in the course of the video, I'm going to construct the questions for you that you are likely going to see for the exam next week. Please pay attention. I've gotten my sample out of the reagent bottle. Now, it's time for me to carry out my analysis. You may be asked to test sample C with a litmus paper. Now, remember, the question will just speculate litmus paper. They won't tell you red litmus paper or blue litmus paper. So you have to carry out the test on the red litmus paper and on the blue litmus paper as well. Now, you have to also understand that from your knowledge in chemistry, any sample that test that gives a positive test with a red litmus paper can definitely or will definitely not give the positive test with a blue litmus paper. So at that point, I have my red litmus paper here. I'm going to take it closer to this sample, even without touching it. What do you observe? This is a damp litmus paper actually. I damped it. What do you observe? Even without touching it, the red litmus paper turns blue, like you can see. The red litmus paper has turned blue. What does this tell you? It means that even at room temperature, this salt decomposes to release ammonia gas. It means to release an alkaline gas, and in this case, it's ammonia. So, your very first question the examiner is going to ask you is to take sample C, take a litmus paper closer to sample C, and what will be your observation? See, sample C turns red litmus paper blue. What is your inference or your conclusion? C liberates an alkaline gas. You say you are done with this question. As simple as that. The next question they are likely going to ask you is to test sample C. To take a spatula of sample C and test with dilute hydrochloric acid. Now let's go. Observe me, come with me, see what I'm saying. I'll use my spatula, take sample C and put in a test tube. You see this? Now, the next thing I'm going to do is to take my dilute hydrochloric acid. This is my dilute hydrochloric acid. What do? I'm going to add about 5 ml of dilute hydrochloric acid. Please observe what happens. Effervescence is going to occur. A colorless and odorless gas is going to be released. Why do you think effervescence will occur? In fact, that at the end of the day, you should be able to answer these questions. Why your tiles in your laboratory, in your chemistry laboratory, are not made up of marble, which is calcium carbonate. Now, observe what happens. Immediately I add this acid, effervescence is going to occur. A colorless and odorless gas is going to be released. And that gas can turn lime water milky. Now, let's confirm that. I'm going to add hydrochloric acid. Did you see the effervescence occurred? Did you see that, please? Did you see that? Effervescence has occurred. A colorless and odorless gas has been if I should test it with lime water, it's going to turn lime water milky. So for this for this second question, your test is C plus 5 mils, about 5 mils of dilute hydrochloric acid. What is your observation? Effervescence occurs. A colorless and odorless gas is being released, which turns lime water milky. What is your inference? Carbon dioxide from trioxocarbonate 4 ions present. Is that understood? Remember, the test with the lime water was a confirmatory test. The next test the examiner may ask you to test, or on the next question, they may ask you to take sample C. They may ask you to take sample C, or let me use this test. I have many test tubes. They may ask you to take sample C, about half a spatula of sample C, and put in a boiling test tube or in any other test tube, and heat gently. They may tell you to heat gently or to warm, whatever language the examiner uses. You should just understand, you should have an understanding of the principle. Remember, I'm not teaching you this for you to cram. I'm teaching you for you to understand why these reactions are taking place and why they are using these steps to test for or to analyze this salt. Now, you'll be required to take sample C and heat gently. Even without heating this salt, or if you heat this salt, a colorless gas with a choking, or a gas with a choking smell, a colorless gas with a choking smell is going to be liberated. And now let me confirm that a colorless gas with a choking smell is going to be liberated. And for you to confirm that truly, if you test it with concentrated hydrochloric acid, dense white fumes of ammonium chloride will form. Please take a look. I have not heated, but even without heating, take a look at this. You see the dense white fumes? These are dense white fumes of what? Ammonium chloride being formed. So the gas form actually has a choking smell. That gas is ammonia. It has a choking smell. I can actually get the smell. It smells, I can perceive the smell. It smells, it has a choking smell. And that gas is ammonia. Now, so at the end of the day, what is going to be your inference? Ammonia from the ammonium ion is being is present. The next test you'll be required to the next test they ask you to carry is to take sample C and add about 5 mils of sodium hydroxide. I'm going to take another test tube. I have many test tubes. On that day, you'll be provided many test tubes. Your school will provide you many test tubes. So this, I'll take my sample and put sample C and put on my test tube. I'm going to add about 5 mils of sodium hydroxide. This is my sodium hydroxide. Let's proceed. I'm going to add about 5 mils of sodium hydroxide to sample C and observe. By the time I add 5 mils of sodium hydroxide and I test sample C with a litmus paper, in fact, even without touching the litmus paper turns, in fact, the litmus paper turns blue, the red litmus paper turns blue. This is an indication, or in your inference, you write that the solution is basic. The solution of C with sodium hydroxide is basic. Now, so for this particular test, the test will be C plus dilute sodium hydroxide, or about 5 mils of dilute sodium hydroxide. My observation will be solution turns litmus, red litmus paper to blue. And what's your inference? Solution is basic. I really hope you have understood up to this extent. The next test they may likely ask you to do is to take sample C, a spatula of sample C, I still have my sample here, and put in a test tube. Let me take another test tube. And put in a test tube. Let me use this. I hope you can see this. I put C in a test in a sample C in a test tube. Then I add about 5 mils of distilled water. Let's see what I'm doing. Approximately. Then I stir, right? I stir with my stirring rod. Thereafter, I add barium chloride to it. So what is the test there? C plus 5 mils of distilled water plus barium chloride. I got my barium chloride here with me. So I'm going to add barium chloride to it. Please take note of the observation. What will be observation? A white powdery precipitate is going to form. Now when this precipitate is formed, this precipitate is suspicious of 3 ions. These 3 ions, when this precipitate is formed, 3 ions are being suspected. The tetraoxosulfate 6 ion, the trioxosulfate 4 ion, or the trioxocarbonate 2 ion. Now, we will need to carry out a further confirmatory test to actually identify the ion which is present. Come with me, let me show you. Please take a look at what happens. Did you observe that? A white powdery precipitate is formed. We say white precipitate is formed. Now, this precipitate indicates the presence of 3 ions, either the tetraoxosulfate 6 ion, or the trioxosulfate 4 ion, or the trioxocarbonate 4 ion. These 3 ions are suspected. Now, we need to carry out a further confirmatory test. That should be around question number 5. So the test is C plus 5 cm cube of distilled water plus barium chloride. Your observation is that a white powdery precipitate is formed. And what's your inference? The tetraoxosulfate 6 ion, the trioxosulfate 4 ion, or the trioxocarbonate 4 ion are suspected. Now, in the next question, the examiner may as well ask you that in question number 5, from the test we carried out in question number 5, add hydrochloric acid to it in excess. I'll take my HCl and add in excess. What do you observe? The precipitate dissolves, right? The precipitate is dissolving. I can actually add in excess so they actually dissolves. So the precipitate dissolves. It has become very clear. Now, remember 3 ions were suspected. We really need to streamline ourselves to identify that particular ion which is present. Now this is what we do. By the time this precipitate was formed, and then you add hydrochloric acid to it. If you added hydrochloric acid and this precipitate did not dissolve, this is a confirmatory test for the tetraoxosulfate 6 ion, SO4 2 minus. If the precipitate did not dissolve, this will confirm the presence of what? SO4 2 minus. But since this precipitate has dissolved, it confirms that the SO3 2 minus or CO3 2 minus are present. But if SO3 2 minus ion, that is the trioxosulfate 4 ion is present, a gas will be liberated which smells like burning match. A burning matches. You know when the smell you get when you burn a match in your kitchen. The gas that will be released, that will be above, will smell like burning matches. Unfortunately, I waded through and the gas above does not smell as such. This is a confirmatory test for the trioxocarbonate 4 ion. Hence, the carbonate ions confirmed. So, in this test now you have C plus distilled water plus barium chloride plus excess hydrochloric acid. You now see that for the observation will be that the precipitate dissolved, effervescence occurs, not so. A colorless and the release of a colorless and odorless gas which comes like water melting, which could as well. That's if the examiner asks you further to confirm with the lime water, the test with lime water. What would be an inference? The trioxocarbonate 4 ions, that ion confirmed, that is CO3 2 minus confirmed. So far, so good. We have succeeded in analyzing this salt completely and identifying the ions, which are what? The tri-orthocarbonate 4 ions and the ammonium ion present. Hence, our salt ammonium carbonate. Do you have any question to ask me? Do you have any question? Okay. Now, any question? Do you have a question?
Yes, sir, I do have a question.
Okay.
I would like
What's
to
the
find
question?
out if we can use any other acid outside hydrochloric acid and
Okay.
barium chloride for this analysis.
Yes, yes, yes. That's a good question. You see, you can actually use triosonitrate 5 acid, that's nitric acid as well, while you use barium nitrate as well to carry out this analysis. So you can either use hydrochloric acid with barium chloride or use barium nitrate with what? Nitric acid. Does that answer your question?
Yes, sir.
Thank you very much. Please, you are going to click to the subscription button, share my video so that others can as well benefit from it. This examination period, you never can tell who you are helping. Please subscribe, share the videos. For further questions, please meet you in the comment section. Drop your comments. I'm going to address your question. I'm also going to drop a contact, which you can actually contact us directly. I'm working with a team of scientists which will be working on different subjects. Drop even more challenging questions you cannot solve. Bring questions you cannot actually answer. I'm going to answer and get across to you. See you in the next video. Thumbs up.